In the previous videos, we have already discussed about how to handle missing values, and also we have discussed about some of the data encoding techniques. So in that, we have discussed about label encoding and then ordinal encoding, and finally we have discussed about the one-hot encoding as well. Now let's discuss about the another pre-processing technique, that is data scaling. So now let's try to understand why data scaling is required at the first hand. So let's say we are having some three features. Let the features be weight, and second feature be height, and let third feature be salary. Okay. And we are able to find some output for suppose. Let's say we are able to find some output with respect to these three features, that is weight, height, and salary. Then let's say this is a regression problem, then the corresponding hypothesis will look like y equal to theta naught plus theta 1 into weight plus theta 2 into height plus theta 3 into salary. So this will be my corresponding hypothesis, right? Now let's try to look into the ranges of these particular weight, height, and salary. So if we in general look into it, what will be the general range of weight if we are collecting the data in terms of kgs? So most probably it might be ranging from something like it might be ranging something like 45 to 150 maybe. And similarly, if we are taking height in feet, then the range of this particular output might be something like some 4.5 to 7. Okay. And similarly, if we take salary, let's be a little optimistic. Let it be like 1 crore to some 10 crores. And then finally, based on this, we wanted to predict this output. So we'll be having multiple data points and their corresponding outputs. And this will be our whole data set, right? And while training, what we'll be doing, we'll be initializing these parameters. Let's say theta 1, theta 2, theta 3 are our parameters. And you guys know, right, what are parameters and all. If not, you need to go and check out the linear regression video because I have explained all the things over there. So please try to check that out. And I hope you know what is the parameter right now. So like these parameters are the ones which are adjusted by the model, right? So now the model needs to adjust all these theta 1, theta 2, theta 3, all these values. But let's see what is the problem that will occur over here. So here our salary is in the range of 1 crore to 10 crores, whereas height is in the range of some 4.5 to 7, which is very small when compared to salary. And similarly, weight, if we take, it is from 45 to 150, which is like some 10 types of height, and this weight and salary, if we compare, the salary is some 10,000 times or 1 lakh times the weight, right? So like the difference in these scales, if you observe, it is too high, right? So because of this difference, what will happen? So if we see this equation, this is some specific mathematical equation only, right? So if we are giving very big number in some specific feature, then obviously these will be some random values, right? Theta 1, theta 2, theta naught, all these will be some random values initially. So obviously this will contribute too much to the output. That is why. And let's suppose this y is in the range of 100 to 700. Let's say our output is majorly in between this one. Then what the model needs to do? The model needs to adjust these parameters in that way, like theta naught, theta 1, theta 2, theta 3 in such a way that whatever input we give, that should be in the range of 100 to 700. If not, the amount of loss will be too high, and it needs to adjust all these theta naught, theta 1, theta 2, and theta 3. And like when the scales are very different like this, what happens? It needs to adjust it too much. Like initially, let's say it is some 5.73. Then from this 5.73, it needs to adjust it into 0.0001. And the amount of time taken for the model in order to adjust from 5.73 to this one will be too much. Okay. And similarly, theta naught value and all these values needs to be adjusted to their optimal values, right? So, and what is the time taken for reaching from normal random model to the optimal model? If you guys remember, it is called as convergence time. Okay. So, and we will always try to reduce this convergence time as well. That is also one of our objectives, right? So that's why what we'll try to do in order to reduce this convergence time, will try to make all of these weight, height, and salary into same scale. So if you are trying to make them into same scale, let's say for suppose we are trying to make all of these into 0 to 1 scale. So weight is now in 0 to 1 scale, and height is in 0 to 1 scale, and similarly salary is also in 0 to 1 scale. Now it might take some amount of time, but the amount of time that is taken for these data to adjust after scaling and before scaling, the difference will be huge. So that is what all the guys have observed. Most of the times, what happens is the convergence time will reduce after scaling. Before scaling, the convergence time will be too high, but after scaling, they observed that this particular time is getting reduced. And that might be due to the reason that we have discussed just now. Because initially, as these are in different scales and the data are some random values, the amount of time taken for them to reduce or to adjust it to their optimal data is too high. As we are scaling it down, we are like helping the model in order to adjust its data quickly. Okay, so that is the idea of this data scaling. And within this data scaling, there are two major techniques. One is normalization, or we can call data normalization, or even we can call it as column normalization. So in data normalization, we'll be interested in checking out min and max values. Okay. So with the help of min and max values, we'll try to reduce the scale from like whatever scale it is in, from that scale to 0 to 1 scale, we'll try to reduce it. And now let's try to understand how we are doing that. Let's say we are having some specific weight values, so in the data set, we are having so many weight values like 53, 57.89, and 63.72. Like that, we'll be having so many values, right? In all these values, what we'll be doing, we'll be finding out the minimum, and also we'll be finding out the maximum. And with the help of these two values, we'll adjust all these values to be like in between 0 and 1. Now let's see how can we do that. 5.73 and 45, 47.89, 93.56, so on 150, and so on 107. Like that, let's say we are having several weights like this. Now, as we find, we know that the minimum is 45 in this. And similarly, what is our maximum? Maximum is 150. So minimum is 45 and maximum is 150. Now, how to reduce this into 0 to 1 range? Simply what we can do, so many of you might think like we can divide it with this max value. Let's say we are dividing everything with the max value. Then as the minimum value is 45, the minimum value will not be zero, right? So what we are trying to make, we are trying to make the minimum zero and maximum to one. So if we are directly dividing it with maximum, it will not make the minimum to be zero. So the scale will be something like 0.4 to 1. So we wanted the scale to be 0 to 1, right? In order to do that, we can do something like 45 minus min by max minus min. Okay. That is, this will be 45, and this will be 150, and this will be 45 in this specific case. Like that, like if we generalize this, let's say the data point is some xi minus min by max minus min. And these are specific to one column. Now we are discussing only weight column, right? And similarly, we'll have perform the same operation or same formula on height and then salary as well. So this is the data normalization technique. Okay. And that's it for this video. In the next video, we'll be seeing with code how to implement this. Okay. I hope you like this video, and like you can comment down if you have any doubts. And thank you for watching. Bye bye.